Welcome back. In this section, we will demonstrate electrical test procedures that are performed after a motor or generator has been serviced, repaired, or is simply being tested for integrity. We will demonstrate, using generally accepted procedures, how to test the three main electrical parts of the motor, namely the series winding, the shunt winding, and the armature circuit. Before attempting any electrical tests, ensure that the motor is isolated from the main supply and that you adhere to the safety procedures laid down by your company and the relevant code of practice. Access to all electrical components is made in the terminal box. All the electrical components are connected inside the box to a terminal block. A wiring diagram is usually affixed to the inside of the lid and will assist in identifying the designation of the various binding posts. The first series of tests we shall perform are called the continuity tests. In each case, we shall measure the ohmic resistance of the windings using a good quality analog or digital multimeter. We suggest that you have an electrical checklist to sketch the connections and record the meter readings in addition to your comments. Begin by setting the multimeter to the ohms position. Clip one of the test leads to the top left-hand post. Probe all the remaining posts, moving from left to right across the terminal block until a reading is obtained. Record the position of the connected posts and the resistance readings on the checklist. Now move the lead to the next post along and repeat the procedure, noting the value of the resistance measured and the position of the connected post. Do this until you have mapped all the posts. As a rule, the series winding will show the lowest resistance, the armature circuit, which will measure slightly higher, and the resistance of the shunt winding will show the highest resistance. Now we move on to discuss insulation resistance testing, where we shall test for a breakdown in the insulation resistance between the series and shunt windings, and test the insulation resistance between the windings and the frame of the machine. We begin by measuring the insulation resistance between the field windings. For this, we use a high-voltage insulation tester, or Mega. To prepare the instrument, set the output voltage of the Mega to 500 volts and select the Megohm range. Clip the test lead onto one end of the series winding and connect the other lead to one end of the shunt winding. Press the test button and note the reading on the Megohm scale. It must read greater than 1 Megohm. A reading less than 1 Megohm indicates a possible leakage path between the two windings. Now move the test lead to the other end of the shunt winding. Test the insulation resistance again. The reading must be greater than 1 Megohm to be acceptable. Remove the test lead from the series winding post and connect it to the other end of the series winding. Once again, test the insulation resistance between the windings and ensure that the reading is greater than 1 Megohm. Finally, remove the test lead from the shunt winding and connect it to the opposite end of the shunt winding. Test the insulation resistance again between these windings. Record the resistance readings and conclusions on the checklist after each measurement is taken. Next, we test the insulation resistance between the windings and the motor frame or earth. Begin by attaching one of the test leads to the frame of the motor. A good electrical earth point is usually available inside the terminal box. Then, with the other test lead, probe and test the ends of each winding and the armature circuit, which includes the interpoles and the brush circuits. Record each measurement and your comments on the checklist. To meet acceptable standards, all the resistance readings obtained must be greater than 0,5 of a megohm. Any reading less than half a megohm suggests a possible insulation breakdown in the electrical system to earth. The final set of electrical tests concerns the circuits contained in the armature. As a rule, the armature circuit consists of the armature windings, the interpoles, and the brushes. Let's first look at the armature itself. We will test the armature coils for an open circuit or short circuit condition. Mark a starting point on the commutator with an erasable marker pen. Then measure the resistance between each adjoining pair of commutator bars. The meter readings should all be similar in value. 0 ohms will indicate a shorting coil, and a high resistance suggests that the coil is open circuit. Continue testing in this manner until you return to the starting point. Update the checklist with the test results. This completes the continuity tests. Now we will test the insulation resistance between the windings and earth. Power up the insulation tester to read continuously on the 500 volt range. Connect one lead to the armature shaft and then probe each commutator bar in turn. If there is no leakage or direct path to earth, the readings will be greater than 0,5 of a megohm. Update the checklist before commencing the next test. Now to check the brush gear. The requirement is to test the insulation between each brush holder and earth. With the brushes lifted away from the armature, measure between each brush holder and earth. The readings must be greater than 0,5 megohms to be acceptable. Having established that the brush gear is clear from earth, we can test the interpole windings. To isolate the interpole winding from the rest of the armature circuit, we must place a short across the armature or lift the brush gear away from the commutator. With the shorting link in place, measure the continuity of the interpole winding by connecting the meter across the armature terminals on the terminal block. As a rule, the winding resistance should be slightly less than the resistance of the series field winding. Finally, we must test each end of the interpole winding to earth to determine the insulation resistance. Connect one end of the insulation tester to the frame of the machine and probe each terminal of the armature circuit in turn, noting the meter reading. The resistance measured must be greater than 0,5 megohms, which indicates that the winding is acceptable. After the break, we'll discuss the mechanical test procedures.